Welcome to the Insightful Professor. This lecture continues our discussion of user-defined types in the Oracle database world. In our previous videos on object behavior, we examined general features of methods for an object type and concentrated on the constructor. With this video, we conclude our examination of object behavior, giving attention to comparison methods and other member methods. Note that without programmer assistance, the database system can only determine whether two objects of some object type are equal. What we have to consider then is what is meant by equal. Equal is a concept that applies to our application domain. For example, if we have an address type, what does it mean for two addresses to be equal? Does it mean they have the same city, state, street, zip code? All of the attribute values are the same? Or is simply the same zip code sufficient? We have to define that when we describe our application domain. When we work with the Oracle database, we can provide a method that will be used by the system to perform an evaluation when we compare objects of the same type. There are two ways that we can provide this. We can create a map method, or we can create an order method. Note that we can have one or the other, but we cannot have both types of methods. In fact, we don't have to have either type. Map and order methods are considered optional. Let's consider how we would approach designing such a method. When we do a comparison outside of the object realm, the values of a scalar data type, such as char or integer, have a predefined order which allows them to be compared. In some programming languages, these data types are referred to as ordinal data types because each value resides in a particular position or order among all of the values of that type. An object type such as address could have multiple attributes of various data types. So this means there's no predefined basis for comparison. So when we consider the meaning of equal, this is an issue in dealing with objects in any environment, not just a database. Furthermore, we also need to consider, with respect to comparison, other relational operators like greater than and less than. First, are they meaningful or relevant for our object type? For example, does it make sense to say that one address is greater than another address? To answer this question, we have to consider details of the application domain. Furthermore, when we do answer the question, our answer may affect our choice of comparison methods, whether we use a map method or an order method. So when defining object types, we have these two options, but we have to give some thought before we decide upon which one. A map method establishes an order over a user-defined type. The map method returns a value that can be used for comparing and sorting objects. The return values may be of any Oracle built-in data type, except large objects and B files. They could also be of a data type from ANSI SQL, such as character or real. So what does the map method do? Well, instances of the type are mapped into some built-in scalar data type. So what is going to be returned by the map method would be one of these built-in data type values. It kind of acts like a hash function. A map method is used by the system for the following purposes. If we have a predicate, a Boolean expression, to compare two instances of an object type, the system will automatically invoke the map method to produce a value which can then represent the object and be used in comparison with values emitted by other objects. The map method could also be used when we have to do comparisons within SQL statements where we have a distinct, a group by, order by, or union. All of these affect the idea of grouping or duplicate removal, which entails comparison. So map methods are automatically called to evaluate comparisons, such as object 1 is greater than object 2, but also when these clauses are used within SQL. Let's note that when you're comparing two objects, such as object 1 is greater than object 2, this is how we would code it within our SQL or within our PLSQL statement. But it's logically equivalent to and could be coded as an invoking of the map method for object 1, comparing the value which it emits against an invoking of the map method for object 2 and looking at its value. So a map method has no parameters, and it must be defined to return one of the Oracle built-in data types. These data types include ANSI standard equivalents, such as character and real. In general, the return value can be any Oracle built-in data type except for large objects and B files. If the object for which the map method was invoked is null, the method returns null. When you define an object type, you can have at most one map method. Remember again that a comparison method is optional. When designing a map method, we must consider how it makes sense to compare objects. Consider a geometric shape like a rectangle. Considering only the lengths of two rectangles doesn't seem sufficient, nor does considering only the widths. If this rectangle represented the surface area to which we needed to install some flooring, such as a carpet, then the areas of the rectangles might serve as a better basis for comparison. In the example we present here, area is declared as a map method and will be invoked automatically by the system when a comparison operation is used. This area function will use the length and the width of the current object to compute the area. One comment we can make about the map method. Previously, we had indicated that an explicit invocation of a comparison method might not make sense. However, in this example, the function could serve a second purpose beyond providing a means of comparison. We could invoke this object to obtain the area of a rectangle object. Thus, invoking this comparison function in a different context does make sense. The other type of comparison method is an order method. An order method makes a direct one-to-one comparison between two objects. For this reason, an order method has two parameters. The first parameter is self, the invoking object. The second parameter identifies the second object to be compared directly against the invoking object. The order method is used by the system when a comparison between two objects is requested. Now, the way the order method returns a value is very simple. What it does is it looks at the current object, identified as self, And if the value of the current object is less than the other object, a negative number is returned. If self is deemed to be equal to the other object, a value of 0 is returned. And finally, if self is determined to be greater than the other object, a positive number is returned by the order method. So unlike map methods, order methods cannot determine the order of a number of objects. They simply tell you that the current object is less than, equal to, or greater than the object that it is being compared to, based upon the criterion used within this function. An order method must return a number, and that makes sense based upon what we just explained. If either object being compared is null, the order method returns null. An object type can have, again, at most one order method, and if it has an order method, it cannot have a map method. So you have either a map method or an order method, or you have no comparison method. But again, remember, if you choose not to create a comparison method, map or order, then the system has very limited capabilities in being able to compare two objects. So let's consider now that we've looked at the overview of these two types of comparison methods, which one would be more appropriate for a particular situation. In general, the name given to a map or order method is not going to be referenced by a programmer. That's because the purpose of the comparison method is to provide the system with some way to perform the comparison. So the method would be automatically invoked by the system. Remember, we did give an example where if we're talking about a rectangle object and we called the function area, and that was the basis for comparison, then it did make sense that the programmer might invoke that. For this reason, the name given to the method is available to users of the system. So which type of method should be used? Well, a map method is useful when sorting a large number of objects. An order method compares only two instances of an object type. For map and order methods, you can compare objects using SQL statements or PL/SQL procedural statements. However, if you don't declare one of these methods, then you're limited in such that you can only compare objects in SQL statements and only for equality or inequality. The reason that a map method may be more useful when dealing with a large number of objects, sorting or merging them, is that the objects are mapped into scalars, then sorts of the scalars can be performed. An order method is less efficient when dealing with large quantities of objects being evaluated because it must be called repeatedly because it can compare only two objects at a time. Here's our friend, the address type. We have a map member function called compare, which will return a character. This is accomplished by including within the body of the function a return statement that returns some character string. So here what we're returning would be self.zipcode, the zip code of the object for which the method was invoked. We're showing the type body here, but we want to remind you that every map, order, and member method that is announced in the heading or specification must be declared within the body. So this function was announced in the heading or specification. Here we're simply showing the implementation. As an alternative, let's look at the idea of an order member function. Again, we jump right into the body. So what we're seeing here is there are two arguments, self, and then something we're calling other. But notice this is within the address object type, so both of the arguments to the comparison function, to the order member method, are address objects. And what we return here is a number. Recall that that is a requirement of an order method. We have to return a negative number, a positive number, or 0. Within PLSQL, we can declare variables of our object type. We have in this example one object called SOMEAddress and another object called OtherAddress. Given that we've declared a map method or an order method, we can now, within PLSQL, conduct a relational expression. For example, if SOMEAddress is greater than OtherAddress, then take some action. In this case, this will cause the comparison method to be invoked for the object. Here's an implementation of an order method. What we're doing again is accepting the current object and some other object as input and returning a number. The number we return is determined based upon the value of the zip code of the current object and how it compares to the value of the zip code of the second object. If the current object has a value that's less than, we return a negative number. We're using -1, but any negative number will do here. If the two values are the same, we return 0. And finally, the last case would be if the zip code of the current object is greater than the other object. We return +1 in this example, but once again, any positive number will do. The existence of a map or order method allows objects to be compared through SQL. An order method directly compares the values for two objects. That is, it makes that one-to-one type of object comparison. When sorting or merging a large number of objects, recall we say the map method is preferable. Let's walk through an example. Here we're creating the employee table where the home address column will hold a column object. We populate this table calling the constructor 3 times. 3 column objects will be instantiated. Next, we use an SQL select statement to retrieve the data from the table, but the result is to be sorted or ordered by the value in the home address column. And because the home address column contains address objects, the comparison method comes into play here. The ordering of the column object can be accomplished by invoking a map method or an order method, whichever we happen to declare for that object. We also note that the order by clause can be used with a row object even without the existence of a map or order method. The reason is that the typed table or object table, the table of objects, can be operated on like a traditional relational table. So that's why in this example, we're creating column objects to show you the specific need for the comparison method. Consider what happens if we have a group by and we have a map or order method available. What we see is, from looking at the data on the previous slide, we have 2 instances of home address containing Main Street, Connecticut, Hartford, and 06120. Those 2 evaluate by the comparison method as being equal, so they are put into the same group. Let's turn to the Oracle system now and provide a detailed demonstration of the points that we've just made. We've run an initial query to show that we're starting with a blank slate. This is an empty schema. The first thing we'll do is create the address type with a map member function. Let's review the code that we just ran. We're creating the type address. We have our 4 attributes, And we've indicated that we have a map member function. We're announcing that in the type, and this will return a character string. The implementation is presented when we create the type body. Here we see that the map function is simply going to return the value of the zip code. We then do the SQL plus describe command to examine the metadata, and we see the structure with our 4 attributes. We see the existence of the member function called getCity, and also our map member function compare. And a constructor is reflected in the metadata output as well. Now we want to do a comparison. We'll start this with a little PL SQL program. In this program, I create 2 address objects, A1 and A2. I actually instantiate the objects by invoking the constructor in the assignment statements on line 5 and 6. And the zip codes are not the same. Now I'm able to say, is object A1 equal to object A2? So on line 7, this will cause the map member method to be invoked. And likewise for the comparison on 10 and on line 13. And it runs successfully, and the output here is presented to say less than, indicating that object A1 is less than A2, and our evaluation was based on zip code, and sure enough, 06100 is less than 06120. So the map method did its job properly. Now let's move to SQL. Our first step is to create the employee table that we've discussed. When we insert a row into employee, the third column of home address will contain a column object for each row. We perform 3 inserts, the 3 invocations of the constructor, and in one row we have 06120, another 06200, and in the third 06110 for the zip code values. We apply these changes to the database with the commit. Then we perform our query. We select from the table, ordering the result by the value in the home address column, because home address is an address object. This will cause the comparison method, in this case, the map member method, to execute. So again, the map member function did its job. Let's go and attempt to create or replace the type. And it tells us we can't because there's a dependent object. This is the reason that we're dropping the table before we try to change the definition of the address object type. When we drop the table first, we are then able to successfully replace the definition of the address object type. So in this definition, on lines 7 and 8, we introduce the announcement or the forward declaration of the order member method. Then in the create type body, we provide the full implementation details. The order member method, remember there's an implied first attribute of self. So self and other are both address objects, the 2 address objects being compared when this member function is invoked. Let's do a describe of address. Let's continue by repeating our compares, but remember we're using a different comparison method now. We begin with PLSQL, and once again execution is successful. Let's take the second compare, which is performed through SQL, And recall that when we did this, we had to create the table to be able to instantiate our column objects. So we create the table, insert the 3 rows, invoking the constructor in each case to create the column object, and then completing the transaction with commit. We run our query, and once again, we're successful. So we see that the comparisons that we performed occurred within PLSQL and within SQL. We were able to perform the same comparisons regardless of whether our comparison method was a map function or whether it was an order function. Performance would be a little bit different if we had a large quantity of objects being compared. The difference would be that the map method could be executed to generate these values, the mapping values, and then those could be arranged in order through a sort, which means that the member method would be called once per object. But with a comparison method as an order method, we may invoke the same method for the same object multiple times because we can compare only 2 objects at a time. We compare object 1 with object 2, compare object 1 with object 3, compare object 1 with object 4, and so on, which means that we're invoking the same method for an object multiple times. So with a large number of values being compared, it would be preferable to do the map method versus the order method. Let's continue the demonstration. We'll change the definition of the address object type. This time, it will have no methods. Prior to doing that, we need to remove the dependent table. And when we review address, we have only structure, no behavior. Now, let's proceed to do the compares. We'll attempt our compare within PLSQL. And it fails. Remember, we're performing or attempting to perform 3 compares: A1 equal to A2, A1 less than A2, A1 greater than A2. Each instance fails, indicating that we need a map method or an order method in order to perform such comparisons within PLSQL. Let's perform the compare within SQL. So again, we'll create our employee table, populate it, and then proceed to attempt our compares. We try to create the table, it works, we insert, complete the transaction, we have our 3 column objects. But when we try the select with an order by, it tells us that we need to have a map or an order method to perform such an operation. Although we give a name to a map or an order method, generally the method is not explicitly invoked. Assume we have the object table addresses. Now consider the following SQL statement and what, if any, practical application it might have. What we're doing is invoking the comparison method. In this case, without a from clause, it's going to invoke that method for each object. Does it make sense to execute or allow the execution of this statement? Furthermore, what is the meaning of the output of the statement? Will it even succeed? Anyway, that's just a point to consider with respect to the comparison methods. Earlier, in a comment about comparison methods, we mentioned that an object could be null. This point is worth discussing. An object whose value is null is called atomically null. This differs from an object which has been assigned null values for its attributes. Think back to the employee table with the three columns being an employee number, a name, and an address. Let's consider some inserts into this table. In the insert for employee 111, the address constructor is invoked to instantiate an object. The object is allocated and each attribute is assigned a non-null value through the attribute value constructor. In the insert for 222, the address constructor is invoked to instantiate an object. The object is again allocated and each attribute is assigned a null value through the attribute value constructor. In the insert for 333, the object's value itself is null. We're not invoking the constructor. This is an atomically null object because the constructor has not been invoked. The consequence of this state is that methods cannot be invoked on an atomically null object. In PL/SQL, if we declare variables to hold address objects, as we've done here, both of these variables are said to be atomically null. Later, when we invoke the constructor, similar to what we did for employee 111 and 222, then these objects are no longer atomically null. Even though the object referenced by A1 contains null values for its attributes, the object is available to us and the methods can be invoked. It is not atomically null. We've presented this point using column objects. However, note that a row object cannot be null. A member method is invoked on an object, that is, an instance of a type. The syntax is the object instance name, the variable, dot method. This method accepts the self parameter. Now, a static method is invoked on the object type rather than an object instance. The syntax is to use the type name dot method. And because static does not apply to any object instance, there is no self parameter. A member method can reference attributes of the object, and both static and member methods can reference other methods. With the statement below, we define a type with a member method. Remember that member methods can be functions or procedures. This definition, being part of the create type statement, is simply an announcement or forward declaration of the method. The type body is what provides the implementation details for a method. Here we create the type body, and this has the same name as the type. In fact, it must have the same name as the type to align the specification and the implementation. Remember that self is passed as the first argument or parameter to the method. So self refers to the invoking object or the object that provides a context for execution of the method. Thus, we have access to all attributes of this object. So here, self.city refers to the city attribute of the object through which getCity was called or invoked. Qualifying the attributes with self is not necessary unless there's some confusion between the name of an attribute and the name of an argument passed to the method. So here we create an object table, a table of address objects, to demonstrate the invoking of a member method. We populate it with 3 row objects. A method is called using a dot notation. Within SQL, the method must be qualified using a correlation variable. If the method has no parameters, it must be invoked with empty parentheses. Here we're selecting getCity, and because we're doing this in the context of SQL, we're using a table alias or correlation variable associated with the table to qualify the call to the method. Although this object table can be treated like a relational table when we perform data retrieval, this example is presented to demonstrate the calling of a method. In this video, we concluded our examination of object behavior, giving attention to comparison and member methods. We discussed two types of comparisons, map and order. Remember that a comparison method is optional for an object type, but if you define a comparison method, you can have either a map or an order, but not both. We explained the behavior and capabilities for the types of comparison methods. We defined what is meant by an atomically null object. And we discussed general member methods and indicating how these could be invoked from SQL and PLSQL.